Hey there, so we're gonna go ahead and get started. I am going to do 4.1. Let's do it. Let's see. All right, 4.1, we have 6 different objectives in this one, and we're gonna be talking about slope. So slope is something that should be familiar from Algebra 1 and also in Algebra 2. And so let's jump right in. Linear functions, we have verbal descriptions or using words to represent this function. A car initially located 30 miles north of the Texas border is traveling north at 60 miles per hour. So it's already 30 miles north of the Texas border and it's traveling 60 miles per hour. And so we can look at a numerical representation, and this is a table. So we have after 0 hours, so at the very beginning, it's already 30 miles north. After an hour has passed, now it's 90. You'll notice here that there's a difference of 60 each time. And the reason is because we've gained an hour. And so every hour, we drive an additional 60 miles over that hour. So that's how our change is happening. This is called a rate of change, AKA the slope. You can see this numerically from this equation. F of x, remember that's just the name of the function, is equal to 60 per hour. So 60 miles every hour. That's that marriage relationship, plus the 30 that was initially there. So that's the symbolic representation that we have. Graphically, we can see that it started at 30, got to 90, then the 150, and the up 60 and over. After 3 hours is at 210, up another 60 and over, 270, up another 60 and over, 330. So every time you're going up 60 and over 1 hour, up 60 and over 1 hour. So you probably remember this as rise over run, 60 over 1. And that's just 60 as your slope. We call this a rate of change. And in this example, for each hour, the distance increases by 60 miles. Okay, so this is an example of rate of change. Every hour, you increase by 60 miles. That is called the rate of change, AKA slope. Slope is the one that has the change. So that's why it's always being multiplied by the x. The slope is the wife. Okay, so symbolic representation, f of x equals 60 times x plus 30. All right, a function f, remember that's just the name of it. You can't do anything with that f, is represented by f of x equals mx plus b. This is where the bread and the butter is, okay? M and b are constants. And this is what we call a linear function, okay? M is 60 in this example, whereas b is 30. M is how we move. We move 60 miles per hour. The B is where we begin. We begin at 30 miles north of the border. So I'm going to say B is where we begin. M is how we move, AKA the slope, AKA the rate of change. This B beginning, AKA y-intercept. This is where we are on the y-axis, meaning when x is 0, where are we already? Okay. All right, so now we get some practice. Example 1 says a linear function f can be written in the form f of x equals mx plus b. Identify m and b for the given function. So m, again, is the one that's married, and it's how you move. So in this case, x's wife is this negative 25. B is how you begin. It's the number that's just chilling on the side, the sideline chick, okay? 40. And the way the textbook says it, I'm gonna erase my stuff. The way the textbook says it is like, you can just rewrite this formula to put it in mx plus b form so that you could always identify the mx first and then the b. But in real life, like, be able to say, hey, this is who x is married to. This is my slope. okay? And then this is the number that's the side check. This is either way, if it came first, second, third, it don't matter. Just know and identify that based on what X is being multiplied by or divided by versus what's being added or subtracted, okay? So B, in this case, if we rewrite the formula, we notice that we have an MX, but we don't have a B. So we have B as 0 in this case. So we have 30 and 0. There was no B, so we put a 0. Okay. Looking at C, I don't see an X. And I don't see anybody that X is married to. I literally only see my B. So if we rewrite this, we put 0X, like there is no X. Okay. So we have 0 in for M and 15 as B. Okay. No, if M is 0, so we just have B, then we call that a constant function. It ain't moving. It doesn't have a rate of change. It's 15 all the time. So no matter what X is, Y is always 15. So on our graph, we basically have a line at Y equals 15. The output is always 15, no matter what our X is, because our slope does not, like our slope is 0. Okay. All right, there's different types of slope. You have positive slope, negative slope, 0 slope, and undefined slope. And so I use this guy called Slope Man to kind of help me remember this. Positive slope starts at the bottom and goes up, positive. Then negative slope starts at the top and goes down. From left to right, it goes down. You see this one going up. Undefined slope is going straight up and down. That's not even a function, because remember, it doesn't pass the vertical line test because it is a vertical line. The slope is undefined. That means that it had to have a fraction where, it has a fraction where it was being divided by 0, and that's undefined. And then flat is going to be 0 slope because it doesn't go up or down. The slope is 0. So you can see Slope Man. He cute. That's how I remember the slope. So positive, negative, undefined, and 0. The slope M of a line passes through the points x1, y1, and x2, y2. So this one, I know you probably saw this in high school. How do you find the slope? There's actually a slope formula, and it is here. Okay. So you have 2 points, and you say, hey, how do I get from one to the other? You check your rise, so the difference in y over your run, the difference in x. So that's called the change in y over the change in x, rise over run. In high school, we say rise over run. In college, we say delta y, delta x, and we read this as change in y over the change in x. Okay. Find the slope given 2 points. Let's actually use this formula and see what works out for us. So be able to write the 2 points down. You got your x1 and your y1, your x2 and your y2. Okay. We're going to actually put them into the equation where it says subtract the y's on the top, subtract the x's on the bottom. Notice that it always goes from y2 to y1, then from x2 to x1. So whichever point you start with, you have to start with it in both cases. Okay. So we're going to do -2 minus 3 right here. This is our first one. And then in the bottom, in the denominator, we'll do the change in x as 1 minus -2. -2 minus -3 gives us -5. 1 minus a -2, you add those two together. That's how we get 3. So -5/3 makes -5/3. What does this mean? This means that the line blank blank units for each 3 units increase in X. So we have an increase in our X change. The change in X is an increase of 3. And it looks like it's decreasing by 5 units in the Y, for the change in Y. So it's falling 5 units, okay? So in this case, if we were to plot those 2 points on a graph, which I highly suggest, now you can see that this is a negative slope. Remember slope man? That's a negative slope over there. It's going down, down, baby. Oh, okay, got it. So from left to right, we had to go down 5 and over 3, +3. Uh-oh. So it falls 5/3 units for each unit increase. No one ever really actually looks at it this way. This part makes sense. It goes down 5 units for every 3 units that it goes over. And that is called rate of change, AKA slope. When you see those words, they are used interchangeably. All right, example 3. The graph shows the approximate number of songs that can be stored on an X gigabyte of iPod Touch memory. Well, dang, we should probably update these slides, all right? All right, iPod Touch. I don't even know if y'all know what that is, but they're not making them anymore. But back in the day, you had to buy it based on how many gigabytes there were, and that would tell you how many songs you could actually save. So if you have no gigabytes, then baby, you can't have no songs. If you have 20 gigabytes of data, that gave you about 5,000 songs. 40 gave you 10,000. 60 gave you 15,000. You see these points on this graph. That's where I'm getting this data from. 80 gives you 20,000. So why is it reasonable for the graph to pass through the origin? Well, if you don't have any space, you can't have no songs. So 0, 0, which is our origin, makes sense. No space, no songs. Okay. Find the slope of the line segment and interpret this slope as a rate of change. So the slope here looks like you increase 5,000 songs every 20 gigabytes. 5,000 songs, 20 gigabytes, an increase of 5,000 again, 20 more gigabytes, an increase of 5,000 again gives us 20 gigabytes. So I would say my rate of change in Y is 5,000, change in X is 20. So we're changing 5,000 songs every 20 gigabytes extra that we get. So if we choose 2 points on this line, the textbook is going to choose 0, 0 and 80, 20,000. And we use our formula. 20,000 minus 0, change in Y. 80 minus 0, change in X. We get 20,000 over 80, which reduces to 250. So they skipped a step. 20,000 divided by 80, which is 250. If we go back over here to my initial concern, when I chose these 2 points, 5,020, that's still 250. So it doesn't matter which set of points you get. When you divide it and simplify it, you will always end up with the same slope if you do your math correctly. Well, what does that mean? That means that for every gigabyte, every 1 gigabyte, you get 250 extra songs. Because this is 250 over 1. 250 songs, 1 gigabyte of memory. Okay. The output increases. The rate of change with the output of units for each input of units. So this is basically the rate of change is the output is increasing with every input increase. The more gigabytes of space you have, the more songs you can save. All right, let's do another interpretation of slope. This one's a little bit more chemistry based. The function P of X, see, remember I told y'all these are just names. You can give it any name you want, A, B, C, D, E, F, G, don't matter. P of X is equal to 19.4X. It calculates the point, hold on, y'all. Okay. P of X equals 19.4X, and it calculates the pounds of carbon dioxide released into the atmosphere by a car burning X gallons of gasoline. So P of X equals 19.4X. This X represents gallons of gas. And once you find the number of gallons of gasoline, you multiply by 19.4, and this will give you the whole thing. The function represents pounds of carbon dioxide released into the atmosphere. Oh no, that's so horrible. So evaluate P of 7 to interpret your results. So we have our P of X. We're now going to find P of 7. So that just means plug in 7 for X. That means we're talking about 7 gallons of gas. How much carbon dioxide for 7 gallons of gas? Okay. 135.8 pounds of carbon dioxide is released after a car burns 7 gallons of gas. Find the slope of the graph of P. So let's look for the slope. Well, all you gotta do is look at the equation. Who is X married to? Ain't no side chick in this situation. So that just means basically, if you didn't drive anywhere, you didn't produce any carbon dioxide. Carbon dioxide only becomes producing when you start burning gas. So that makes sense for us to have a B of 0. But the M, how we move our slope, is 19.4. The M is what the X is married to. The slope, 19.4. Interpretation, this means that 19.4 pounds of carbon dioxide are released for each gallon of gas burned by a car. Each gallon burns 19.4 pounds of carbon dioxide. Okay. All right, so all of that was about linear functions. Now we're going to look at nonlinear functions. If a function is not linear, then it's called nonlinear. Okay. First off, let's talk about what linear is. Remember, linear is a line, and it comes in the form of mx plus b. Or of course, we're using function notation. F of x equals mx plus b. And it's usually a line, or it's always a line. That's it. So anything that's not a line, boom, boom, not a straight line, is nonlinear. So if you have something like this, nonlinear. Something like this, nonlinear. Something that look like that, nonlinear. Nonlinear. Anything with curves, not linear. A function that does not have a constant rate of change. Remember that rate of change, that slope? If it don't have a slope, it's not linear. And that means it cannot be written in this form. Okay. All right. So, quick question. Is this nonlinear? Yes, nonlinear. This is nonlinear, it's not a line. This is nonlinear, it's not a line. This is nonlinear, even though it has 2 lines, this is actually absolute value. And because it doesn't go straight like that, that means it's nonlinear. That's pretty simple. Anytime you see something that is not a line, it is nonlinear. Okay. Determine if f is a linear or nonlinear function. If f is a linear function, determine if it is a constant function. So This time we don't get to look at our graphs. But if you had a TI-84, you could totally graph these and see what they look like. But the way you look at these and find out is if it can be written in the form f of x equals mx plus b, then it is linear. If you cannot write it in this form, that means it's non-linear, okay? I'm gonna slow it down right here because this is really important. For A can be written in the form mx plus b. Put the negative 17x, put the positive 4 at the end. There you have it. Slope, y-intercept. This is linear. It's not a constant function because it has a slope. That means it's changing, it's moving, it's going up or down. In this case, it's going down because our slope is negative. For B, do you think it's linear or non-linear? I'm gonna say that this one is non-linear because it has absolute value. Absolute value looks like a V. So it's non-linear. Okay. C, this has an exponent. That means it's a parabola. That's not a line. Therefore, non-linear. D, it's just a number. So that does tell me it's a constant function. And it is a line, it's just a flat line, there's no slope. This can be written as f of x equals 0x plus 4. No slope. So this is linear and it's constant. Okay. This one, it has a square root symbol. So that is like a root. It's not a line, therefore it is non-linear. So literally, if it has anything other than a slope, an x, and a b, or just a b, or just a slope and an x, anything other than this would be considered non-linear. Decide whether a line can pass through the data points. If it can, determine the points. So for this question, we get a table. And remember, okay, first up, I'm sorry. Any part of this video that you need to stop and pause, rewind, do that, okay? Don't just keep going and I'm going fast. Stop it, rewind it, make it make sense to yourself, okay? But we need to see if there's a constant slope. Like on the very first page, we had a constant slope. We looked at 60 every hour, 60 miles every hour. Well, let's see if there's a constant change. Like this one, there's a change in 5. Change of 5, change of 5, change of 5. Change of 1, change of 1, change of 1, change of 1. Because there's a constant rate of change, then yes, this is going to be linear. To find that slope, just choose any 2 points from the graph and use the point slope formula. I mean, the slope formula. Or just know that it's the change in y over the change in x. So it's 5 over 1. That's your slope. But if you wanted to keep the formula thing going, 0, 10, and 1, 15. So we're going to say 15 minus 10 for changing y, and then 1 minus 0 for changing x. Uh-oh, moved too fast. And you get 5. Okay. All right, we're doing it again. Let's see if there's a constant change. This looks like it went down 36. This went down 20. This went down 12. It's not the same number being changed every time. So it's not constant. Okay. Y'all see the difference? Let's go back to the letter A. Every time we were adding 5, every time we were adding 1. On this one, it's not the same number every time, so therefore it's not linear. No line can pass through these points because it's not the same change for every change in X. That means it won't be the same change every time, so it will not have a line. It's gonna curve. So therefore, the answer would be no, it's not linear. Okay. All right, so this time we get to kind of see what we just looked at in action. You have like data points, and you can see like those data points are moving down and back up, and just things are happening, and it's not a linear change. So you have decreasing parts and increasing parts, where if it's a line, it's going to be strictly increasing or strictly decreasing, or undefined, or no increase and no decrease. Those are the 4 options for a line. But in a nonlinear function, you can have different things happen. That's how you get the curves. Okay, so on this graph, from left to right, it looks like, and I will tell y'all, a lot of people struggle with this. So pause this right here and make it make sense, okay? You are increasing, slowing down. Get to a point where you're not increasing or decreasing. You're just kind of chilling, and you change direction to where you start. Uh-oh. Did not mean to do that. Hold on, y'all. At some point, you then start to decrease. Okay. So going back, you are increasing from negative infinity. Increase until you get to this line on the x-axis. Until you get to 0, x equals 0. So you are increasing from negative infinity to 0. And then at 0, you start your descent. You start decreasing forever. Okay. So we're writing this in interval notation, and we're just trying to see when is the graph going up and where is it going down. Okay. So this part of the graph, this blue part, from all of these numbers, from negative infinity up until 0, this graph is increasing. Okay. This green part of the graph is going down from 0 forevermore. You can't include the endpoints because it's not increasing or decreasing at those particular single points. I think it's really important that we go back and do this one again. So I'm going to come back and explain this one more time. Trust me, I'm explaining this because it's important. It's on your test. It's not only on this test, but it's also on your final exam. So pay attention, okay? There are 2 different parts of this graph that we're looking at. You have a y-axis, you have an x-axis. When we're talking about increasing or decreasing, we are literally just looking at the x-axis like a number line. Okay. This graph is increasing all along this side of the number line. It is decreasing. Sorry. From here on. Okay. So if I just drew the number line for the x-axis, I will be decreasing from 0 that way. And I am increasing from increasing from negative infinity to 0 and decreasing from 0 onward. So if I have to write that in interval notation, I am increasing from negative infinity to 0. I am decreasing from 0 to infinity. That is so important. Okay. So if you don't understand this, watch it again. Okay. I'm moving on. We're going to look at a different example of this. So what helps me in doing this is always to write it as a number line, because it just, like I said, it just helps. Okay. So looking at this, it looks like it's decreasing up until you get to -2. Okay. Then it starts to increase between -2 and 2, increasing this entire time. Again, from left to right, it's like, how would you draw this with your pencil? Would you be going up or going down? It looks like I'm going up. From -2 to 2, I'm increasing. And then I start to decrease again. From 2 on. And notice I'm just looking at the numbers on the x-axis. I don't care where I am on the y-axis. I'm just looking right here. The -2 and the 2 are where the changes happen. Okay, so that's what we have. So when I had to write my intervals, we have going down negative infinity to -2. It's increasing from -2 to +2. And it's decreasing again from +2 to positive infinity. So that's how you see this. Pause it again. Make sure you make it make sense. We'll talk about it in class tomorrow. Number 9, the graph shows the amount of A, water, in a small swimming pool after X amount of hours. So here we have 0 hours, 0 gallons of water in the pool. After 2 hours, we got some water. After 4 hours, baby, we full. We got 500 gallons. We keep those 500 gallons for 2 hours, from 4 to 8 for 4 hours. But then we start to drain the pool, so it's decreasing. So it's increasing constant, then it starts to decrease. Okay. Let's see what the question is asking. Find the x-intercept and interpret what they mean. So these are the x-intercepts. That's where it crosses the x-axis. So we got 0, 0, and 12, 0. That basically means at 0 hours, there was no water in the pool. And after 12 hours, there was again no water in the pool. The water had been drained all out already. So that's that. Now it says identify where it's increasing and decreasing. Well, it looks like we're increasing from 0 to 4. So for the first 4 hours, we were increasing. Well, because they're defined here, I think it's cool that we have a hard bracket on 0. This thing gives us soft brackets, and I think that's kind of weird. But I would have put hard brackets if I were you. If I was doing this problem as a student, yeah, I put hard brackets. It's decreasing from 8 to 12. Again, I would have hard brackets. Okay. Note that the pool contained 500 gallons between 4 and 8 hours. And that's when we would say that the interval is constant. All right, let's do another another rate of change problem, but this time we're looking at average rate of change. Importante, okay, this is important and very important, okay? Remember I told y'all nonlinear functions don't have slopes. So we can't find the slope of a line when it's not even a line. We have to find the average rate of change. So what we'll do here is we'll find the average rate of change of f from the points 1 to 2. So we're picking points on this line and we're still going to do slope, but it's not actually called slope this time. It's called the average rate of change. Okay. So we're finding the slope of the line between these points, even though it's not represented by a line. Okay. So we'll do the exact same way using the same formula and everything. Changing y over changing x. So take that y minus that other y, that's changing y. X minus the other x, that's changing x. -3 minus 0 is -3. 2 minus 1 is 1. So our average rate of change is a change of -3. Okay. So again, it says you kind of can look at the graph and see that this was a drop of 3 over 1. And that's totally fine if you can do it like that. That's how I do it. But if you want to use the formula and remain consistent and get good practice of using the same thing over and over, then this formula never changes and it's always going to stay the same and it's legit. Okay. Talking about the same problem, but now we're going to do the average rate of change from a different angle. We're going to look at -2 to 0. So from here to here. Now this looks like a positive average rate of change. Okay. So we're going to use those 2 points, -2, -3, and 0, 1. Okay. Uh-oh. So basically we say 1 minus -3 over 0 minus -2. That becomes addition and that becomes addition. And then it's 2. So the average rate of change is 2. Okay. So of course, we're not actually finding a slope. We're just finding an average rate of change. Last question we have, I can't even say that, Torricelli's law. A cylindrical tank contains 100 gallons of water. So the cylinder looks something like that. It has 100 gallons of water. A plug is pulled from the bottom of the tank. So then what happens? The water falls out. The amount of water in gallons remaining in the tank after X amount of minutes is given by this formula. So at first they have 100 gallons, but it starts leaving. So they have this random formula that allows us to say how fast that water is leaving out of that tank. Okay. And so it says calculate the average rate of change from x equals 2 to x equals 2.5. Remember, x is just minutes. So after 2 minutes, from 2 minutes to 2.5 minutes, how much water is still in the tank? This is not a linear function. So the water not leaving at a constant rate, it's leaving at some weird rate. So we have this formula, a of x equals 100 times 1 minus x over 5 squared. Lord. So what we'll need to do is we need to find the values of a of x after 2 minutes and after 2.5 minutes. How much water is really left? Then we can find the average rate of change. So we need to calculate a of 2 and a of 2.5. So a of 2 means put in 2 for x. And you'll find that that's 36 gallons left. After 2 minutes, it's only 36 gallons left. And after 2.5 minutes, it's only 25 gallons left. So we're going to use those points to match 236. After 2 minutes, it's 36 gallons. After 2.5 minutes, it's 25 gallons. And we're going to plug those into the slope formula and find the average rate of change. 25 minus 36 and 2.5 minus 2. Negative 11 over 0.5, which is negative 22 gallons per minute. So between 2 and 2.5 minutes, that water was falling out at about 22 gallons per minute. And we say falling out because it's negative. The water is leaving the tank at an average of 22 gallons per minute. That's crazy. And that's it. That is 1.4. So